Hi everybody, this is Chandra again. Today I want to talk about, this is my lecture 5. I want to talk about repetitive execution or loop structure. Why repetition is needed? Because it saves space, it saves memory. That's why. So we can create a loop to save space. The most important loop here is a while loop, and the while loop, as you see, it checks an expression. If it is true, it executes the statement. If it is false, it gets out. Here is a simple example for a while loop. Over here, we start with I equal to 0, and then we what we do here is we increment I by 5, then we print the value of I, and this process is repeated as long as I is less than or equal to 20. When it exceeds the 20, the condition becomes false, so we get out of the loop. This is how a while loop works. And we explained this before. If I is less than 20, then we will not print 20. Instead, we're going to stop at I equal to 15. And the while loop is often a count control loop. The previous example is a count control loop because we are looking for I to become less than or equal to 20. Alternatively, we can also have a sentinel variable, and if the variable value is not equal to sentinel, we continue in the loop. Otherwise, we get out. The sentinel can be a distinct number like minus 99 or minus 1000 or whatever. The third option is we want to control a while loop with a flag. Initially, the flag in the example is set to false, and there is an expression inside the while loop which sets found equal to true. As long as found is false, we continue to stay in the while loop. When it becomes true, we get out of the loop. We can also control the while loop with end of file marker, which we will discuss later in the class. And the next most important loop is a for loop. For loop has three components. One, initial statement. Two, a loop condition. Three, a loop update. And the body of the loop may have one or two statements. And here is a flow chart. First, we do initial statement, and then we check the condition. If the condition is true, we execute the body of the loop, and then we also execute the update statement. When the condition is false, we get out of the for loop. And here is an example. In this example, you notice I equal to 0 is initialization. It's executed only once, whereas I is less than 10 is a condition. When I becomes equal to or bigger than 10, we get out of the for loop. Then the loop update here is I plus plus, which means we increment I by 1. And as long as I is less than 10, we print its value. And here are two examples. In the first example, Notice the loop has two statements inside it, which means it is going to print hello, and on the next line is going to print the star for 5 times, because we put a curly bracket that includes both the statements, whereas in the second loop we only have no curly bracket, we have one statement in the loop. So here we print hello 5 times, and at the end we print star once. So I want you to see the difference between these two uh, loops and the effect of using blocking or a braces in the performance or in the operation of the loop. A loop can also proceed in the backward direction. Here we notice we start at I equal to 10, and then we keep on going down. As long as I is bigger than or equal to 1, we stay in the loop, and every time we decrement I by 1. In that way we output starting from 10 all the way down to 1. And over here the loop increment statement is not 1, rather it is 2, right? Which means I go 1, then 3, then 5, 7, 9, and so on. Okay, as long as I is less than or equal to 20, I am going to print the value of I. At the end I print a new line character. And there is a third loop structure called do while looping, which is very similar to while, with the exception that the condition is checked at the bottom of the loop. And furthermore, the do while structure guarantees at least one iteration of the loop, because we don't check the condition at the top. Instead we check the condition at the bottom, so consequently we execute the statement at least once. That's a big difference between a while and a for loop. And here is a flowchart that explains the operation of a do while loop. As I said, we execute the statement first, then at the bottom we evaluate the condition or expression. If it becomes true, we execute the statement again. If it falls, we fall through. And here we show an example that the same task is performed using two loop structure. One is a while loop, the second one is a do while loop. Okay, I want you to study this and try to understand what's going on. And choosing the light loop structure, my preference is I always use a for loop because it's more general, and then I go for while loop. But I don't think I'm in favor of do while loop. It is my matter of preference. So read the criteria for selecting the loop and try to be a fan of at least a couple of loop structure. And we also use a break and continue statement in a loop. The break statement causes premature exit from the loop, whereas continuous statement allows you to stay within the loop. And notice we have a nested loop, which means there is one loop within another loop. So here the I loop is outer loop, the J loop is inner loop. So for every I we have to do a J loop. So consequently it is easy to see that the code is printing the star pattern as it is shown above here. In the first row we print the first star, the second row we print the 2 star, the third row 3 stars, and so on. We can also print the star starting from 5 star all the way to 1 star by changing the outer loop as shown above. In summary, there are three important loop structures, and I want you to read the summary, and I want you to do the quiz that I will post in the black box in the blackboard, and you bring it back to the class next time. Thank you.